Good evening, ma'am.
Yeah, good evening, Kirtana. What were we doing in the last class? Have you done the revision of that part? Kirtana,
Yes, ma'am.
so any doubt from that part?
No, ma'am.
I know that you didn't do the revision, right?
I did it yesterday.
Huh?
I did it yesterday, ma'am.
And you found no doubt.
Yes, ma'am.
Mhm. Well, in the last class, we have discussed about enthalpy, right? And we have said that as there is a change in the volume that takes place in cases of gases mostly. So we can say that the difference between delta H and delta U becomes significant only when we have gases. Because in solids and liquids, there is no significant change in volume. Na? So if there is no significant change in volume, it means delta H and minus delta U will be a minor one, right? Right? Am I audible? Am I audible?
Yes, ma'am.
Yeah. So we have formulated a formula for enthalpy that is delta H is equal to delta U plus P delta V. This is our general formula that we can apply for either solids, liquid or gases. But if we have a case of gases only, so in that case, we have a specific formula for enthalpy. Okay. Now the thing is that what is that formula? If we have a gas basically, so we have two gases, like if we are having a reaction. So there will be a volume for the reactants and the volume of the products, I can say. Can I say this thing? If I am having a reaction, means reactants are getting converted into products. It means some volume will be there for the reactant and some will be for products. So I can say that VA is my volume of gas reactants and VB I can say volume of gas products. Can I say this thing?
Yes, ma'am.
A second thing I can say that number of moles of reactant. N is number of moles of reactant that are reacting in a reaction. And NB is my number of moles of product. I can assume it. है ना? As we know that we have an ideal gas equation that is PV is equal to nRT. So if I write an ideal gas equation for reactants and for products separately, so for reactant I can say that PA is equal to NA as R is a constant and T is also constant. And for products I can write it as like this, PVB is equal to NBRT, right?
Yes, ma'am.
And what is the difference between product minus reactant? It will be PBV minus PVA is equal to NBRT minus NART. Correct? This I can
Yes, ma'am.
write P delta V is equal to delta nRT. Right? I can write this thing.
Yes, ma'am.
I know that P delta V is what? It is delta H minus delta U. So for cases of gases, I can write it like this. Delta H minus delta U will be equal to delta N RT, where my delta N is basically the difference between the gaseous product minus the gaseous reactant. Suppose I am having this reaction. It is forming this one. Now I am having all the things reactant and product in gaseous state. So 1 mole minus 2 mole means product के moles जितने भी हैं उसमें से क्या minus किया reactant के moles, then I will get minus 1. So that -1 will be the value of my delta n.
Yes, ma'am.
Clear? Now I'm
Yes,
giving
ma'am.
you a question, just try to solve it. If water vapor is assumed to be a perfect gas. Now I'm telling you that I'm giving you a question of a gas. Molar enthalpy change for vaporization of 1 mole of water at 1 bar and 100 degrees Celsius is 41 kilojoule per mole. Enthalpy change has been given to you, means delta H has been given to you, right? Calculate delta U when 1 mole of water is vaporized at 1 bar pressure and 100 degrees Celsius. Just do it. Is the question is clear? Kirtna, is the question is clear to you? Kirtna?
Yes, ma'am. Ma'am, is it minus 790?
What's your answer, Kirtana?
Minus
What's your
790.
97? How do you do that
My
question?
delta H minus delta U is equal to delta N naught 2.
Huh. So delta H has been given to you, that is 41. What is delta N in this case? What is delta N, Kirtana?
1,
1. And what is R?
8.31.
Yeah. And what is T?
100.
No. We have to take the temperature in Kelvin only. Always take temperature in Kelvin whenever do the numericals of thermodynamics.
Okay, ma'am.
Just do it. Done, Kirtana? Kirtana? Kirtana, are you there? Kirtana, are you there? Are you there, Kirtana?
Yes, ma'am.
Yeah. Is the first question is clear to you that how to do that one?
Yes, ma'am.
Tell me the delta N for the second case. Because the process is same, only the delta N will vary.
Ma'am, can you explain the second one?
Yeah, what is the delta N coming out in the second case? As we can see that water is converted into ice now. So water has a physical state that is liquid and ice is having a solid. So we can only find delta N for gases. In this case, as liquid is getting converted into solid, so no gas is there. So my delta N will be equal to 0. If my delta N will be equal to 0, my delta H will be equal to delta U, right?
Yes, ma'am.
So my delta U in this case will be equal to 41 kilojoule per mole. Here.
Yes, ma'am.
Next, we have a concept that is called extensive and intensive property. Basically, we have properties that either depend on the size of a pattern or some properties are there that do not depend. If I say that I am having a container and the temperature of that container is 100 degrees. So if I reduce the size of that container, will the temperature of the container also decreases? If you are having a 5-liter water with you and the temperature of water is 35 degrees Celsius, if you reduce it to 2 liters, then will the temperature of the water will reduce?
No, ma'am.
No, na. Similarly, like if you have density, if the density of water is 1, then either I am having 5 liter or 100 liter, it will remain the same. है ना?
Yes, ma'am.
So the properties that do not depend on the size, we call them as intensive, and the properties that depend on the size of matter, basically, we call them as extensive property. So these are the properties basically that depends on, clear hai?
Yes, ma'am.
Quantity of size of matter present. And intensive is do not depend on quantity. Clear? Next, we have a concept that is called heat capacity. Heat capacity was basically if you want to increase the temperature of any substance by 1 degree Celsius, then you will provide heat through that substance.
Yes, ma'am.
So basically, heat capacity is the amount of heat that you will provide to any substance to raise its temperature by 1 degree Celsius or 1 degree. Okay. So we
Yes,
can
ma'am.
say that amount of heat required to raise. Kirtana, tomorrow you will have a test.
Okay, ma'am.
Of which
Of this
chapter?
chapter.
Yeah, that I'm waiting for that you will ask. Coordination.
Okay, ma'am.
Okay. Amount of heat, and you will submit it to me in the form of a PDF and you will send me the copy. Then I will check.
Okay, ma'am.
Okay. Heat capacity is basically it is the amount of heat required to raise the temperature of given mass by unit degree. Clear? So as we are providing the heat we represent by Q. है ना?
Yes, ma'am.
So we are raising the temperature, so we can say that delta T. And to remove the proportionality sign, we have a C, that is a constant. This constant is my heat capacity. Clear? Next, we have specific heat capacity. In this, I have written that amount of heat required to raise temperature of given mass. If I have fixed the mass quantity also, like 1 unit mass is there, and I have to raise its temperature by 1 unit degree, then I will say that this is the specific heat as I have fixed the fixed the quantity of mass also. So I will say it is specific heat. Clear?
Yes, ma'am.
So it is the quantity of test you will give by making your video on.
Okay, ma'am.
to raise temperature of 1 unit mass of substance by 1 degree. Clear है? Again we have Q is equal to delta T. Okay? This is my heat capacity as I have specified a unit mass, so I will represent it by this one. This is my capital C and this is my small c. So I can say that my capital C will be equal to this and this. Means my heat capacity will be equal to specific heat capacity. Clear?
Yes, ma'am.
Any doubt in this one?
No, ma'am.
Next we have a relation between Cp and Cv. Now what is this Cp and Cv? C is basically heat capacity at constant pressure and heat capacity at constant volume. C is my heat capacity, right?
Yes, ma'am.
If I write my heat at constant volume, then what it will be equal to? It will be equal to delta U. We have discussed earlier. And for constant P, it will be equal to delta H. That we have also discussed, right?
Yes, ma'am.
We know that delta H is equal to delta U plus P delta V, right? So delta H we can write QP, delta U we can write this one plus P delta V. We can write this thing.
Yes, ma'am.
I know that P delta V will be equal to what? N RT, N R delta T, है ना?
Yes, ma'am.
N I can consider as 1. So QP is equal to QV plus R delta T. Can I write this thing?
Yes, ma'am.
Now QP I know that C delta T. So I can write Cp delta T is equal to Cv delta T plus R delta T. Delta T
Yes, ma'am.
cancel. Cp minus Cv is equal to R. It is the most important relation that we use.
Yes, ma'am.
Clear hai?
Yes, ma'am.
Just have a quick revision of it. We will do only this part only. Today, complete this heat capacity. Okay? Just go through this.
Ma'am, can you scroll? Ma'am, can you scroll? Ma'am, what is the answer for the question first one?
Exact answer I need to calculate Kirtana. The values that you have told me now all were correct actually.
Okay, ma'am. Ma'am, can you scroll it?
Just wait.
Ma'am, can you scroll it? Ma'am, can you scroll it? Ma'am, can you scroll it? Done, ma'am.
Okay, beta. Any doubt?
No, ma'am.
Okay.